Hello, everybody. Glad to see people are coming in, spending their day or your Friday with us for this part two of our webinar series. But yes, thank you for being here. Awesome. Well, I think we can go ahead and get started here. Uh, we'll have a few more people attend later. But so just to give you a quick little summary or a recap on our webinar series, we have this once a month, fourth Friday. Glad to see a lot of people attended. And this is a continuation of our last webinar, which was basically the idea of going from a bar top napkin dream to an actual part sitting in your hand, right? So series part one, we kind of dwelled into the CAD side of things. How do we design? How do we draw? How do we sketch? How do we model things? How do we bring reference models in, make things look very realistic as an assembly, so that way we get a better idea of how our part's gonna look. So all that we covered in our part one last month. The YouTube video is actually up. So I will put the link here at in our chat at some point, or my co-host, Mr. Brown, would also put it in there if you guys want to just, go back and see part one too. That's available, and we'll have this recording also available soon after we completed today. So look out for that. Tell your friends, tell your colleagues where you found out all this cool information, and always follow us for more cool content like this. So today what we're going to do is like I said, we're going to continue off of part one. Today we're going to look into more of the manufacturing side of things. So we'll be taking a look at our bike rack that we did last time, right? So just to give you a wrap up again, we went through, how do we prepare those ideas, the CAD drawing and the assembly. We ran some simulation on it, some FEA, to make sure that it's cool to draw something. We need to make sure it actually works in real life, right? So we ran some load analysis on it, checked to make sure that we've engineered this or built this to the right specification so it can hold X amount of bikes. And then we went ahead and created, after we made sure everything looked good in simulation, we went ahead and created some machinist drawings or manufacturing drawings of our parts. That way you can go ahead and dimension them or basically prepare all of your 3D solid models for manufacturing, right? So that's kind of what we did on our last one. And then again, just as a continuation, I want to touch on what the real goal of this was, right? So we just had some leftover material from our previous project, some aluminum tubing. And then I'm building this based off my little gravel bike. It's about 30 pounds, right? We made some custom molded straps for the blocks that you can sit on there on the frame. And we're doing this all so that it's compatible with a Ford F-150, right? So the hitch receiver was designed for about 2.5 inches of internal width. So today, what we're gonna cover is how do we get from those prints? How do we get from those paper prints to an actual finished part in our hand? In order to do that, we're gonna cover two of the major types of manufacturing that you can do for mass manufacturing or also on prototyping. So we're going to do a little bit of the 3-axis milling, some 3D printing, and also we'll look at maybe, let's just say we went ahead and our bike rack looks pretty good. We wanted to make like a bunch of these parts. How do we use things like patterning or some other form of manufacturing to help us maybe automate the process of programming these parts, right? So we're going to look at all of those today. So we're currently on step 5. We've reached step 5. We're going to do milling operations, some turning operations, and 3D printing. All right. So without further ado, let's jump into Fusion. Now, if you remember our part from last time, you'll notice it was a little bit more rudimentary. So while I had the time, I kind of went in there and added a few little details that I thought it'd be fun to use to actually manufacture or set up some 2D operations on our tubings. For example, the slot, just to reduce some weight. We're also going to go ahead and create our own pins for that, right? And then also you'll notice that I made some cool little improvements to a little mold here. I went with, yeah, I wasn't able, I was my brain, I had a lot of brain fog, so I thought yeah was the best thing to put on there. So but since this is all technically new, I did want to extend the opportunity to anybody here on the webinar today. Let me know if you're interested in wanting to find out how I went about doing all this, creating an emboss so you can customize your parts. So if you'd like to see more on that, I'm happy to do that. Just put it in that Q&A section, and we can do a quick walkthrough of it, probably maybe at the end of our goal today. All right. Basically what I did was I kind of just made it look a little funky and look a little cool, so that way it'll justify the reason why we want to 3D print this, right? Also because 3D printing is fun. So that's why I did it. Awesome. So what we're going to do is we're going to break this thing apart, right? We're going to go ahead and let's start off with this tubing. It's going to cover our general milling operations. And then we'll go ahead and we're actually going to turn this pen. We'll cover a lot of our turning operations. And then we're going to jump in and do the 3D printing. All right. So basically what I've done here is, remember last time we were kind of working on the design workspace. I have now switched to the manufacturing workspace. So the cool thing, this is where you go ahead and add all of your operations as far as the type of manufacturing platform you want to work on, right? So we got milling, turning, additive, inspection, fabrication, and some other cool stuff. So for today, we'll be mostly doing milling, turning, and the additive. All right, so what I like to do is when I create these setups, I don't need to see the whole thing, right? So I'm gonna hide a couple of different things here just to make sure that we need to see exactly what we need to see. So under my models here, I'm just gonna go ahead and say, hide our bike rack holder. Let's hide some of these tubings. Let's hide our turning pin. And let's hide this top right here. So this is part number 1 that I'm going to be working on today. So we're gonna imagine a few things just so that we can it's a little easier to kind of picture how this is all going to get created. So I'm going to put this on just a simple 3-axis mill, and you're probably holding it on maybe a couple of vices or something like that, right? As part of your work holding is concerned. And all we're really going to do is we're going to go ahead and mill these. We're going to mill the ends to make sure that we are at the right length for our tubing. And we also that we can get a nice little finish on them instead of possibly a saw cut finish, right? And then we're going to go ahead and cut up these slots as well, right? So let's begin. I'm going to go ahead and set up a new setup here. Create a new setup. As you can see, Fusion 360 automatically kind of detects your probable stock sizes, what's a possible orientation for our part. Now, all of this can be changed in the setup dialog box right here. Pretty much under the operations section here, all you really have to do is, personally, what I like to do, there's a couple different options, but I like to select the Z-axis and the X-axis. So what we're doing is we're referencing faces to align that Z-axis in the right direction. So I'm going to click on this top face right here. And as you can see, our X is automatically being orientated for us. Now, you technically actually don't have to select an X-axis if you're already in the right direction. But again, if you want, just pick an edge that's parallel to the direction, and it should keep it consistent. Next thing is our origin point, right? Where do we actually want to go ahead and set this origin point? So because we're already cutting it from a piece of tubing, we're pretty much already at width and height, right? It's just a piece of square tubing. So what I can actually do is, instead of saying I want to base my origin off of some box points, right? You'll notice that there's a clear difference between a stock box point here and then something like a model box point, right? So we can get pretty technical with where we actually want to set our origin, but I'll tell you, just to keep this thing simple, I'll tell you right now, you can go ahead and just use something like a box point, and we can set it up right here in the center. That way we make sure that we're taking equal amounts on either side, and we're setting our Z right at the top here. Easier to set our tools. All right. Next thing is our stock. Within our stock tab, as you can see, it's just there's a couple of different modes in how you want to actually have the shape of your stock. You can go with a fixed size box, meaning that you can come in here and physically type in what your stock specific sizes are. And then you can also do it through a relative size. And what Fusion does, it, like I said earlier, it looks at the model, overall model dimensions, and then you can actually add, you know, a certain amount of material on the sides and the top, whatever you want to take off. So so we can actually have it set to relative size stock here. And then what I'm going to do is I'm actually going to say there's no stock on the top, right? Because we are at the size of the tube. And we could just say, for example, there was like maybe 100 thousandths or a quarter of an inch we need to take off the total length. So I'm going to go ahead and say 0.125, meaning what it has done is it adds about 1/8 of an inch on either side of your part. Okay. Another way to do this is you can also, like I said earlier, just do it through a fixed size box and then add your actual X width. Let's go ahead and do that actually. So I'll say 75, as you can see, a little bit more accurate. Now we got about 1/8 of an inch on this side. And the winning point of using this strategy is it doesn't add any stock on either sides of it. All right. So that kind of covers exactly what we want to do with our stock. I'm going to jump into the post-process tab here. And pretty much, again, just to keep it simple, there's nothing really need to change on here, except, for example, if you did want to do multiple different offsets. And we can cover that towards the end here when I want to talk to you about how do we manufacture multiples of these after we figure out our prototype. So it looks good, right? I'm going to go ahead and hit OK. And what will happen is now it'll just run this particular setup on all of your programs just the one time on the one work offset. All right, so let's go ahead and let's throw some toolpaths in here. So first thing I want to do is I want to cut the ends to the right length. So simply using a operation like a 2D contour, which is available under all of our 2D content right here. All we really need to do is it's going to pop up this little dialog box. We're going to run through all of these little tabs, give you an explanation of what each thing does. So if we're going to start off here with our tool tab, simply selecting tool will pop up your tool library, right? Now you can create tools and custom tools and things like that. You also have the availability of using Fusion standard sample library. Most of the tools in here are pretty good just to kind of, get yourself started with the tool. So I'm going to go ahead and actually choose one out of my library here. Say it's a flat end mill. Maybe we'll use something like a 3/4 inch flat end mill here. I'm going to go ahead and hit select. There we go. We get a little preview of what our tool looks like. Next thing what we need to do is we can go ahead and change our speeds and feeds as required, right? So for example, if you're running something like, so this is going to be steel, mild steel, you can change your surface with speed. And don't yell at me for speeds and feeds on here. We're all a little different, right? So I'm going to go ahead with something like 350 for a surface foot, possibly. I can feel like people are yelling at me. That's too slow. That's too fast. So after that, all you pretty much need to do is add the feet per tooth. And now the feet per tooth can be calculated based on the amount of flutes that you actually have on the tool. Let's go a little bit modest and let's say about 3 thousandths or maybe 4 thousandths feet per tooth. Gives us, as you can see, it auto calculates our feeds here for us because all of these run based on expressions. So just by actually filling out your surface foot and the feet per tooth, you can go ahead and get all of your RPM values and your feed rate values. Again, if you're kind of new to the process, all of these numbers can be found through your vendor information, through their websites, or through a catalog, or even there's ample other resources that you can find online today. Next thing I'm going to do is I'm going to jump over to my geometry tab. Now in my geometry tab, pretty much all I need to do here is guide my tool in the direction that I wanted to cut, right? So I can go ahead and simply say, I want to use this chain right here. and then spin this thing around one more time and say, I want to use this chain right here. So simply by hovering over certain edges, Fusion 360 will give you the capability of picking them as your chains. If you ever wanted to edit your chains, you can go ahead and click on the chain one more time. And then as you can see, it throws you up into the editing mode. Now, I can get ahead of the problem here because if you notice, this particular chain doesn't actually start from outside of our stock, outside of our tubing. It kind of starts right here, which I'm probably going to want to avoid, right? I want my tool to come actually from the outside. So just a quick little simple edit of my toolpath here by just including these two possible edges. And you always got to hit that plus sign. Make sure you hit that plus sign. And you'll notice we actually was able to extend our chain out a little bit so our tool can actually start from the outside. One thing we do want to make sure, however, is we make sure that our red arrow here, the pestle red arrow, needs to stay on the right side for your tool compensation. Awesome. I'm going to repeat the process here on the other side. Now, this isn't the only way to actually extend a toolpath out, extend a chain. There are some other ways to do it. And the other ways to do it would be using something like a tangential extension distance. And all this really does is it looks at the chain where it starts and will add, you can add an offset value, which means it'll increase the distance from where it starts and stops based on that starting point of the actual chain. All right, so there's a couple ways to do that. But I always think the best practice would be to kind of make sure that your chain looks good and you actually edit the chain before you try anything else. Okay. Awesome. That covers exactly where we want our tool to go. Next thing I can do is in my heights tab. And I like to tell people to keep things very simple when you start programming on Fusion 360. You don't actually need to adjust too many values because the default values are pretty good to start off with. Now, not to say that you can't change these if you want to make your toolpath maybe retract a little bit less and you want to, make it a little bit more efficient. You can definitely go ahead and change these values. But as a default, I would say that they're pretty good. The main thing, oftentimes when I get asked the question, what should I be looking for in the heights tab? Most of the time I tell everybody, kind of look mostly towards your top height and your bottom height. This value here is really what controls where you start your toolpath and where your toolpath ends as far as the Z level is concerned, right? Now for your bottom height, you want to make sure that you're set to selected contours. So that means any contour any chain that you pick, it's going to set up that Z chain, the Z level based on where the chain position is, right? Another way to do that is you can also change it to a couple of different options. For example, like model bottom. As you can see, if I change it to model bottom, it sets it right here at the bottom of the model. And then you can also use something like selection and then actually pick a face that you want to cut to. And this is pretty handy. For example, if you wanted to set your finish depth to something a little bit higher, you can always use selection and then pick a sort of an edge, a face, and even points. All right. I'm going to keep things, again, like I said, pretty simple. I'm going to go with model bottom here. I do like to always go ahead and put a little bit of an offset so that my cutter can go just way past it so that I don't end up with a weird lip or anything like that. So as you can see, any offset you add in here, negative or positive, will affect the direction of your final cut. Next thing is our passes tab. In the passes tab, this is where you can control certain features like maybe you want to add a couple of roughing passes, or maybe you want to do this with multiple depths, right? So the passes tab is where you come to control all of that. So like I said, you can check on the box of any sort of feature that you want to add, and you can add roughing passes clearly just by putting maybe like a few passes in there, 2 or 3 passes, and then adding the step over that you want your cutter to take on each pass. You can control that right here. Or you can also do with multiple depths as well, meaning that instead of stepping over, you'll be stepping down, right? So you can choose your preferred method. Some people like to do roughing passes. Some people like to do multiple depths. I'll go ahead and add some roughing passes in here. Maybe I'll add about 2 passes, right? Because we're only taking about an 1/8 inch stock off. So, and then I'll say maybe we can take about maybe about a 16th on each pass. How about that, right? The reason why right now it's saying it's giving me a red warning here is because it's telling me that my roughing step over is actually smaller than my finishing step over. So how a roughing step over is different to a finishing step over is the fact that this right here is the amount of stock it'll take in your very final pass, right? So typically when I want something to end with a really nice finish, I'll go ahead and maybe make this a very small cut here on my last pass, just so it's almost like a little dust cut almost, right? So in that way you can go ahead and make sure your tool doesn't deflect too much and cause any sort of chatter on your very final pass, and gives you a really nice finish on the edge here. So that's what I'm going to do. You can also choose to leave stock if you'd like to. We're not going to do that. We're just going to cut everything right to 0 here. And the very final tab here is your linking parameters. Again, really, there's nothing much you would need to change in here. But if you really wanted to make a very specific lead-in angle or a lead-out angle or things of that nature, then you can custom change those values, right? And I'll make a few changes just to show you, a few possible scenarios where you might want to actually change it, right? So I'm going to go ahead and hit OK. As you can see, we have our first 2D toolpath right here. Our cutter is going to come in, make a couple of swipes, and then cut that final pass there for us. All right, and this happens on both ends because we selected 2 chains on either side. So like I said earlier, I want to kind of show you why you would want to go ahead and, for example, make this 0 degrees here on your leading sweep angle. And now, as you can see, we're spending a little less time trying to turn our tool into a part. All right. So next thing what I'm going to do is I'm actually going to go ahead and throw maybe like a pocket toolpath in here to rough out these slots, right? So now if you wanted to, you can go ahead and do this on one setup and cut it all the way through, or you can just rotate this to the other side and run the same program, right? So in order to keep things moving here and program a little faster, what I'm going to do is I'm just going to kind of do all this in one full setup. So I'm going to use a 2D pocket again. I'm going to use that same 3/4 inch flat end mill. As you can see, we have it already brought up here, technically because it's the only tool we have in our library right now. Go into that geometry tab. Again, simply kind of doing what we did earlier, selecting this bottom geometry here, right? Going to go ahead and say, I want to cut all the way through the model bottom. Again, giving it that negative 50 thousandths to make sure we don't have a weird lip at the bottom. What we're going to do is we're going to add a couple of multiple depths, right? Because we want to cut all the way through. So I'm going to go ahead and maybe we'll take about 150 thousandths a pass. And then I'm going to go ahead and hit OK. So as you can see, what Fusion has done is went ahead and threw a pocket toolpath for us. So we actually go ahead and cut that and cut that. Now, if you feel like, well, that's a lot of time, I'm just wasting, just ramping down here without material, you are right? So maybe we can split that toolpath very quick. So what I'm going to do is I'm going to say, hey, I want to, instead of using that chain at the bottom, I'm going to use this chain right here. And in my heights tab, I'm going to go ahead and make a selection and say right here. There we go. We went ahead and fixed that pocket toolpath now. And now what's cool is quite simply, without having to actually create a whole new toolpath, I can right click on here and say duplicate, create a new pocket toolpath, choose a new chain right here at the bottom, have it actually start from here and end at the end of my model. Let's see what that toolpath looks like. And there we go. So as you can see, we saved ourselves some time instead of ramping all the way through it, doing a top cut and now a bottom cut. You would simply repeat the same process and pick chains on either side. So I'm going to quickly do that here on my first one. I'm going to pick this guy too. And then I'm going to say, pick this chain as well here at the bottom. All right, quite simply after that, what I'm going to do is I'm going to quickly add a chamfer tool. So to do that, I'm just going to go ahead and say, for example, you can use a 2D contour or a 2D chamfer, or even a trace toolpath. Let's throw in some diversity here and use a trace operation. I'm going to go ahead and select a ink chamfer mill from my library here. Let's go with like just a little smaller tool here, a 1/4 inch. And as you can see, all I really need to do is click on this line right here, that chain, and that chain right here. Really, since I'm picking the chain that I want my tool tip to be centered on, I don't really need to mess with any of the other chamfer widths or chamfer tip offsets. The heights can all stay consistent. Might need to raise the stock size just a little bit further up, maybe. There you go. Hit OK, and there's our chamfer toolpath. So just like that, we're actually done milling this part. I'm going to go ahead and right click and say simulate. Let's see what this looks like. So now if we go ahead and simulate it. All right, so just to keep things moving here, let's go ahead and jump into our pin, right? So that's going to be our next setup. So we're going to do a little bit of turning on here, and I'm going to go ahead and bring up that pin, hide the tube. Here's our pin. Simply creating a new setup for a turning operation. As you can see, Fusion automatically detects that this is a cylindrical type of part. It's going to put my operation type set to turning. All I need to do is select the right Z. I'm going to go ahead and flip that Z axis around, right? And then I can also choose an X axis if I wanted to, but I think I'm just going to leave it off for now. And even with my stock, I can go ahead and add a certain length that I want, anything I really need. There we go. There's our turning operation all set up now. And now we can start adding toolpaths to it. So quite simply, just by clicking a turning profile roughing here, selecting a tool, I'm going to choose something off from our Fusion library right here. Oh, select the wrong tool. That's a left-hand tool. Let's go ahead and select the right-hand tool. There we go. Perfect. Stating my front and my back. Stating the radii clearances. Again, all of these default values are pretty good. As you can see, I'm not really changing much. All I'm really doing is picking on our tool. And honestly, at this point, I can actually go ahead and hit OK. And look at that. That right there, that's a pretty good toolpath, right? Similar to that, simply going ahead and saying, well, now that I finished my roughing, I also want to throw a finishing in there. You can choose a new tool. Let's go ahead and choose a finishing tool. Let me see, do we have anything that's in here that's a finishing tool? That looks pretty good, doesn't it? Let's use this right-hand finishing tool right here. A little bit of a sharper corner radius. Again, all I did was select a tool, add the feeds and speeds as needed. Looking at your front and the back values, where you want to start and where you want to stop. The radii clearance values here show you where your outer diameter is and your tool clearance diameter. And then on your passes tab, you can go ahead and add another step over if you'd like, or just the final step over as well. What I typically like to do is also maybe add like a little spring pass to it. So then that way, if I did have any sort of tool deflection, I can come back, or chatter or a really bad surface finish, maybe I can have that tool path repeat itself and do one more pass to make it look good, right? I'm going to go ahead and hit OK. And there you go. So you'll notice that it doesn't really take too long to actually have a program created on a turning operation. As a recap, all I did was just pick a tool and hit OK, to be honest. It's all model aware as far as the turning operations are concerned. So we don't actually go in here to pick any sort of 2D chains or anything that the tool will follow. It automatically just looks at the surfaces and then creates a toolpath for us. All right, so there's our pin. A few more things I just need to do here is I need to go ahead and put this cross hole, right? So this is where it gets cool. So this is mostly for everybody who has probably some live turning features on their lathe, so mill turn. We can actually go ahead and use tooling operation to clock this hole and then have our drilling operation done inside of our lathes too. And I'll show you how to do that. So simply, I'm just going to go ahead and create a drilling operation. After I select the right drill, pro tip, if you actually go ahead and go to tool orientation first before you pick your actual geometry, what tool orientation does, it basically, you can use a feature, a cylinder or edge or face or anything you want to now orientate your z-axis in line with the axis of the hole, right? I'm going to go ahead and flip that z-axis one more time. And you can also flip the x-axis if you need to. Now I can actually go ahead and pick that hole face because I'm in the right z orientation, right? If you actually, if you hover over the hole, as a pro tip, it'll give you the diameter so that you don't actually have to go back in there and choose a measuring tool and then come back and figure out what the hole size is. So all you gotta do is just hover over the hole, it'll tell you the diameter. Neat little trick that I like about Fusion. So now I gotta just go ahead and select the proper tool for it. So it looks like it's just a 3/8 hole. Going back into my Fusion sample library, filtering things using the type here. And all I need to do is look for a 3/8 hole, drill, I'm sorry. So as you can see, everything's kind of organized according to diameter. I'm gonna go ahead and select my sample drill here. That looks a lot better, right? So you'll notice though, that by selecting that cylindrical face, right now Fusion isn't accounting for this little countersink that we have on top here, or chamfer. So simply just by clicking on this feature called Auto Merge Hole Segments, it probably won't work in this situation just because this isn't a full cylindrical face. As you can see, it's split right here. But ideally what this would do is if anytime you had a counterbore or a countersink, Fusion can automatically detect any sort of circular faces on top of it, and they adjust the start height to actually start on top of the countersink or the counterbore. So in this case, I'm going to have to do it a little bit more manually, which isn't too bad. I get to show you guys how I do that. So as you can see, our top height and the bottom height, like I said previously, is something that you probably need to pay attention to the most. I can go ahead and add a little bit of an offset there, maybe 150. Now, as you can see, we have that drilling operation starting right on top of it. And then as far as my bottom as well, I can go ahead and say, hey, I want to drill the tip to the bottom and also maybe add a little bit more of an offset. There you go. So that'll take care of drilling it from the top to the bottom. Now, what I've skipped doing here is probably, using like a center drill or something a little bit more stubbier or sturdier to make sure that we could have a good pilot hole so that when our drill walks in here, it's just not gonna get deflected since it's coming down in a circular face, right? But as far as creating that operation, you're gonna do it exactly the way I did it here, just by selecting a center drill and possibly going in just the required amount here, maybe halfway or 100 thousandths or so. Next thing is the cycle. In the cycle, you can actually select what type of drilling operation you want to do, right? So you could simply go in and out. If you had a nice stubby carbide drill, you don't really would need to peck, right? Or if you did have something a little bit more like a high-speed stainless drill, you can go ahead and add like a pecking chip break on there. So there's really two types of chip breaking. You can do a chip breaking that's only a partial retract or an actual full retract, right? I'm going to go with a partial retract, meaning the drill actually never leaves the hole all the way through. You can adjust the pecking depth to your liking, whatever you want to take on per depth. And that's pretty much it. I'm going to go ahead and hit OK. And there's our drilling operation. So the only real difference, like I said earlier, as a recap, you had to turn on your tool orientation on so that you can clock the orientation of the hole to your spindle, and then go ahead and drill that hole. Makes the whole process of doing it in one setup a lot easier. The next thing that we can do again here is probably just add a 2D trace operation and cut that chamfer, or we can even use something like a contour. So when you are in a turning operation, you can still go ahead into milling and create milling toolpaths. So simply I would say 2D either contour or trace. Let's do another trace here. Use that chamfer mill. As you can see, it auto picked it. So this is the last one that we were using. Turn on auto orientation one more time. Go ahead and select the Z-axis. Go ahead and flip that Z-axis. You can also use the wheels here, in my case, to align it to a specified angle if needed be. But typically just clicking a face would do the job. And then after I actually do my, like I said earlier, the tip that if I want anyone to take out of this is make sure you turn on your tool orientation first, and then go ahead and actually select your curve. All right. And again, that's pretty much all I'm going to do. I'm going to leave my heights the way they are. My passes, I'm just going to kind of leave that the way they are. And even the linking, just leave it the way it is. Hit OK. And there we go. There's our operation. So again, like I said earlier, what's really cool about this is I can also use things like duplicate. And all I would need to do is go ahead and flip that Z-axis, right? So we can turn it around. Pick our new chain right here on top and hit OK. Easy peasy. We got our trace operation on one side, got a trace operation on the other side. So we're pretty much done with our pin as well. We can add a part off operation too. That way we can actually get the part out. Simply go into turning and saying turning part. Next thing I need to do is just select a tool for it. Again, I'm just going to go into Fusion sample library here and use something like a turning groove operation here. Go ahead and pick the appropriate tool. As you can see, Fusion automatically detects where the back end of the part is. And you can also choose if you want to put a little bit of edge break on it. So it cuts it for you. Go ahead and hit OK. The yellow line that you see right here is the stock that's left over or the stock that's remaining. The whole reason why is because our rough profile and our finishing profile didn't actually cut out all the way, right? So in order for me to extend that, I can simply go ahead and say, well, I want to increase my back distance a little bit just to see what will I get from it. Hit OK. Now, as you can see, that looks a lot better. In our turning up part here, as far as my back is concerned, I want to make sure that that is set to 0. That way it's going to cut everything right to size. Hit all right. So I'm going to simulate this just so you guys can see what this looks like. Oh, just went a little faster. So that roughs out our pin, finishes our pin, drills a hole, and we part it off. So we're 2 components down out of the 3. And it probably only took me a whole of 30 minutes or so to get all my components done. So the last thing I want to show you is how do we set up a 3D printer to print something in plastic. All right, so here's the little insert I have. Again, just to remind you where it goes, that goes into our bike right here. All right, so I'm going to go ahead into this now. In my manufacturing workspace, what I'm looking is for the additive section, simply just creating a new setup. As you can see, what Fusion does, it automatically kind of puts it in this little box here. So I'm going to pick a machine for it. We're going to do just a generic FFF machine. Hit select. All right. The next thing that we need to do is pick our print settings. In my print settings, the Fusion 360 online library has some sample settings that we can use for different types of materials. You can also, have your own personal ones if you have them. Let's go ahead and use this ABS 1.75 millimeter here. I'm going to hit select. And that's pretty much it. I'm going to go ahead and hit OK. Now, the nice thing about this is, as you can see, that's probably not the most effective way for us to actually 3D print this part, right? So simply running a tool like the automatic orientation, right? As you can see, we have selected our component here. We can adjust certain values as far as what is the threshold for our overhang angle and things like that. But if I go to my parameters here and add all that and hit OK, I'm going to let Fusion automatically figure out what is the best way to actually orientate our part inside of this 3D printer. So we'll give that a few seconds here. Shouldn't take too long. And then while that's happening, there's some other tools that you can also use inside of the 3D workspace, the additive workspace. For example, if you wanted to manually position your parts, you could just use move components. Oh, unfortunately, I can't show that to you because we're doing a study on what the best way to do this is. But it's pretty much what that'll do is it'll just bring you a little wheel, and you can either rotate it, translate it, and place it to the way that you want to orientate it on in the printer. A few other things is, for example, like your minimized build height. This is really cool if you're running, let's just say, multiple parts or a really complex type of part with a lot of geometry on it. The minimized build height can also orientate it in a way where you can go ahead and try to keep things as flat as possible without having it stand too tall in the Z direction. So as you can see, it spits out these orientation results. This is what I really like about it. It gives you some preferred rankings. So as you can see, this is our initial setup. If I hit 1, this Fusion is telling you that this is probably the best way to actually orientate this part inside of the machine. So it takes a lot of that guesswork out for you, and it also saves you a ton of material, a ton of time. So this is something that I pretty much use for all of the parts that I toss into a 3D printer, just so that I know I have it set to the optimum orientation. Now, there are some other ways you can actually orientate it, and it gives you this the ranking of it. So as you can see, this is another good way to set it up. And there's 9 possible ways it gives you. Your 9 is sometimes pretty much your initial one, but it changes in certain different directions. So we're going to actually go with our number 1 preferred orientation here, hit OK. And pretty much next thing that I can do is go ahead and generate this additive toolpath. I'm going to let that take a little time and let that go ahead and print, calculate. And while that's happening, like I said earlier, you can also go ahead and have parts placed automatically on a platform if you needed to. Let's just say it's hovering over another part, or you just weren't able to move it to have it sit completely flat on the table. Using place parts on platform is a good way to do that. Collision detection is another nice way of trying to figure out if you're going to bump into parts. If you try to print multiples of them, it'll tell you if the parts are either connected or they're bumping into each other. And also in the supports, you can decide how do you actually want to create supports. Do you want to do solid volume supports? You can also do solid bar supports. The solid bar support is kind of cool because it really kind of helps you minimize the amount of support material you're printing with, and making sure that it only creates support where it thinks structurally would be necessary. The solid volume is a little bit more of like, it kind of deals with your cross hatching that's inside of the part and things like that. So as you can see, it kind of went ahead and generate our toolpath for us. Let's do a quick little simulate. It's going to go ahead, and as you can see, we can play it, or we can also just kind of drag this and see what sort of layer by layer visuals I have. It's just simply by hitting the play button. As you can see, it's going ahead and printing that layer by layer for us. So as you can see, it's not a very complicated way to get something quickly on an idea, a model, and then just throwing it onto a 3D printer and building your first prototype. If it looks good, if it works really well, you just found a way to also fine tune your design as well, make some improvements to it. And it's typically low cost if you're just kind of making one for yourself, right? So that's how you would go ahead and set up a 3D print. Now, as far as actually posting this out to your machines, simply right-clicking it, saying post-process, will bring up the post-process window. You have to just make sure you have the right machine settings on there and the post settings, and then going ahead and hitting post would give you your NC code that you would then plug into your machine, and then away you go. Similar to the 3D printing is your milling as well. You would do pretty much the same thing. Just gonna jump back into manufacturing here so we can see what those toolpaths look like. And simply what you would do is you would go ahead and right click on any one of these toolpaths here, hit that post processor button, make sure that you have the right machine setup, make sure you have the right post setup, and you should be well on your way of spitting out the NC code. So you just went from a part setup in your machine or some tubing that was in your garage to an actual finished part that you can assemble and set up a bike and take a little trip out to the trails. So just to give you guys a little recap on what we covered today, right? We set up, how do we actually set up something on a mill? How do we do these milling operations? How do I get an end mill to do what I needed to do, right? So as you remember, we just kind of picked a tool, picked a chain, changed some speeds and feeds, it's a couple of different features on how you would want to mill something as far as doing maybe multiple depths, roughing passes. So after that, we went ahead and created that pin, and that was just simply doing some turning operations on our lathe. On top of that, we actually turned it into a mill turn operation as well by being able to do cross holes and things of that nature. And we went ahead and also prepped a 3D print to go ahead and print up our little grab block. If there aren't any other questions there, guys, again, I just want to thank you so much for coming to the webinar. Feel free to follow us on our YouTube channels or all our other social media channels as well. We'll always have content like this coming out, and we'll see you on the next one. Thanks for attending.